Hi everyone, today we're going to talk about maximizing and extending your machine learning capabilities with Signals Infusion. My name is Mark Moyu. I'm a data science manager here at LucidWorks. Feel free to email me at the email below. And my intention is to make sure you get the most value out of Fusion AI. Let's begin. The three things I want you to really walk away with from this talk. The first is, why should you honestly care about signals? Some of you may be thinking about it. Some of you may already be getting quite a lot of value from it. And we're just going to redo what that means within your business, be it you're an e-commerce vendor or you're doing internal search or customer support. Next is talking about what we offer from a machine learning perspective and how we've solved some of the common problems in search so we can help you get up and running very quickly and make you focused on more impactful problems in the business. Lastly is you can extend the machine learning capabilities of our platform by bringing your own machine learning to the platform without doing any type of infrastructure change. And this is one of the first platforms on the marketplace to do this. So we think it provides a lot of value. First, why should you care about signals in your business? Remember that signals are very important to any size of e-commerce business, and it is also important in digital workplace environments or internal search use cases. Let's focus on the first two words on the screen, click and collect. Everything that your users are doing, there should be some record of it in order to make your search engine smarter. From a definition standpoint, we're going to define signals as any user interaction in addition to the context that is around it. So a user interaction could be a click, a cart, a purchase, all these different things that someone can do on your site to indicate intent. Context has to do with who is the user, maybe their user ID, their location, time of day, all of these different surrounding pieces of information that give us much more insight as to why someone is doing something on your platform. And the thing I'd love for you to remember is that without signals, you're not able to provide a personalized user search experience. So as we barrel down the personalization realm, this is very important. Simple statement, we're going to say that using your signals means you're listening to your users, right? No business ever went bankrupt by obsessing about their customers. So this is a way for you to obsess about your customers by delivering some of the best experiences that they can get. And we want to make sure that you're listening to the users in order to leverage the signals that they give you. The image that you see here is someone slacklining between two cliff edges. Slacklining is a very interesting sport. If you've never done it, it requires a lot of balance and you have to use everything about you to get from one side to the other. So we all want personalization. We want to delight our users. So let's start. Typically, we do lexical-based search, meaning the text has to have matching overlap in order for us to return more relevant results. But as users expect a better search experience, we have to incorporate more and more machine learning to get ourselves to machine learning powered search to deliver the ultimate experience. In order to get there, there are three things that we have to focus on. These things called user behavior, algorithms, and infrastructure. However, algorithms need data. And if you have a scalable search platform that does not return the great results, it's not as useful. So the user behavior is tremendously important in delivering that best experience. The users are going to fuel your platform. It's plain and simple, and you want to make sure to give them the best for what they're giving you every single time. And just remember, for instance, when you go on Google and every time you search on Google, Google is getting better at providing you a better experience. So you should also do that for your users. Let's take a look at e-commerce and think about what is it that an e-commerce user wants. There are 5 things here, and a search engine is supposed to provide these 5 things essentially in order to convert. So for instance, are the products that I'm seeing, are they relevant to me? Can I actually buy it right now? right? There are many products that happened during COVID that were not available because of shortages. Is it the right price? And the right price meaning, is it the best price for my pocket based on what I've done before? Social proof is quite interesting, where we think about taking in user ratings in addition to style trends that you see coming up. So analyzing query behavior to see what things are trending. And lastly, personalization. There are lots of items on your site I may not want to see. Can you use signals to actually drive a better experience there? Let's take a look at how signals influence e-commerce conversions. At the top, you see 4 boxes: understand the user ask, user behavior, influences to a category, and context aware. The dash boxes represent things that you can achieve with implementing signals. So let's start from the left. We want to understand the user's ask, and there are different things that we can do to achieve that. One is the proximity of the search, understanding the intent, maybe taking into consideration where's the user coming from. User behavior, this is more centered around all of the different types of user interactions that can happen on your site where we can infer intent. So the standard ones are clicks, add to cart, purchases. Some could be how long are you on this page. Other interesting ones are cart view and checkout. Initiation, where you can to some degree determine the probability that someone will abandon their cart and different things based on their prior interactions. Influences to category, number 3, that's kind of grayed out, is focused on what are all the other things that sort of influence a purchasing decision or even just an add to cart decision within an e-commerce environment. And those things have to do with, do you actually have a lot of ratings? Do you have badges, promotions? But those are not necessarily purely centered around signals. And lastly, context aware, that's the surrounding information. Where are you? What have you done before? Building this type of knowledge about who you are without being invasive, right? And that's a big thing that we'll definitely focus on. Taking a look at a customer story, Lenovo achieved quite significant gains by implementing signals on Fusion. The 3 things I want you to focus on are, the dramatic increase in revenue. That's what's fantastic. We always like when our clients make money. And in addition, the increase in relevancy, right? So users started to click things that were closer to the top of the list when querying the system. And the last one that I want you to sort of walk away with is this shifting of the culture within the Lenovo search team and sort of broader customer-facing teams in there, recognizing that the signal information that was being generated on the Fusion platform and in their search application was actually quite tremendous for them to push more relevant results to their users, in addition to understanding purchasing behavior, best performing products, these types of things. So this notion of query analytics becomes very important and only possible if you have signals. Next, we're going to focus on digital workplace. So I'm in a digital workplace environment. You might be thinking, hey, that's great. All those things you just talked about for e-commerce are fantastic. What can I do for internal search? Or if I'm just doing simple customer support. Here are 5 things that we think some digital workplace team members want. When I make a search, is the document relevant, right? And the significant difference between search in e-commerce and, let's say, in digital workplace, the text is a lot longer, the queries are quite different. And do you understand my history? Search history in digital workplace environments tends to be a little more long form, meaning like it's more repetitive because I'm searching kind of the same documents over and over. And what have other team members on my team done that I can learn from? So this notion of knowledge transfer from experienced people to less experienced people becomes very important. Who should I call to solve a problem? This is something we're seeing a lot of customers ask for, right? Areas of expertise. We have clients who have, up to 20,000 employees and trying to find who's the best fit for handling particular tasks. And lastly, this notion of similar documents where, hey, I'm looking at this document. For instance, I'm a lawyer. What other cases should I be looking at, right? This is a slightly different use case to pure search. And this helps to fast track things like patent verification and other things like that. Let's take a look at a similar diagram to what we saw before, but now applied to workplace. Understanding the user ask, same thing, how closely does the search match things that we've seen before, understanding the intent. And I put this thing here called question answers because as an organization, you want to be very aware of what data it is that you're collecting, right? So question and answer pairs, you may actually be answering a lot of questions for your users, and you can train deep learning models on that to automatically answer those questions. Why could that be important? Because deep learning models will handle the question variation, so you don't have to do a lot of templating. And as you collect more and more signals, those algorithms learn to answer questions much better. In user behavior, you can see the interactions are slightly different. People are still clicking. Sometimes you may like or bookmark. You can download different things. So the type of interaction has changed, but we're still focused on how interested is a person in a particular document or item within the application. Influences to the category, oftentimes in digital workplace environments, there is a lot of access restriction depending on your level within the company. So that will influence some of the results that you bring up, but you can always collect all of those signals and then enforce that access restriction later on. And context aware, understanding, hey, what were your recent searches? That's a big thing, just to ease the search experience and make sure everyone can move as quickly as they need to. Customer story, Dynatrace. There was one search architect there who implemented the entire search on Fusion, which is quite incredible. And he did it all on his own with very little support. The 2 or 3 things I want you to focus on here are he was using signal boosting, and he applied it to actually doing user-specific boosting to make sure that people had all of their personalized results. And ultimately, people were finding better documents. And lastly, he was getting a lot of valuable information to continue improving his search through signals. To sort of conclude on this section, these are some elements that you want to collect in your signals as you sort of move along to make sure that you can get the most out of our machine learning algorithms. In addition to yours, we always encourage clients to collect even more contextual data around a query, but these are sort of fundamental, right? What query did you put in? What is it the thing that you interacted with? What department, or who are you, meaning like your brand affinity on the e-commerce side? Who are you as a user ID? So protecting PII is very important. So we don't need to know your name and these types of things. You can just give us a user ID and we can abstract that, and you can have a separate layer that handles all of that rematching to protect personal information and when did these events happen and where are they coming from. Next 4 slides, we're going to look at this type of progression, and what I want you to take away from there is what is the common challenges we kind of see as you move along the signals and machine learning journey. First, you're considering signals, you're on this nice carbon fiber road bike, and the thing I'd love for you to remember is without signals, your relevancy is limited, right? So in order to get better relevance, you definitely need to push down the signals path. First is, how are you going to gather the signals from the UI, right? We've kind of shared some of the fields that you should be gathering, but that's often a pain point. How do you ingest those signals and then process them? Do you do that all within your single search platform? Do you have a separate infrastructure to actually handle that and you're piping the results over? Next is, you might be collecting Google Analytics data, different types of data that's coming from the site. How can you now leverage that to enhance your relevancy, not just look at more of an analytics view? What if you're implementing signals? You're on this road bike, on this dirt bike, and you're in the process. Can you collect more context in addition to a greater type of interaction? So going beyond the click, cart, and purchase, let's say in e-commerce, and moving to like page dwell time, that's a little more work on the front end. And if you're on the digital workplace side, looking at things like downloads, interacting with comments and all those types of things, just to get greater levels of intent. How do you actually start processing the signals at scale, right? If you're not a big scale client, you don't have millions of searches a day, this may not be a concern for you. And then after you process the signals, how do you leverage your output into a search pipeline? Is it repeatable? Is there a lot of custom code that you have to write? Next, you're on this super fast bike, but you're out in the wild, and you've actually collected signals. You started some machine learning. You have a small data science team. What's very important that we recommend to clients is making those signals searchable, so that downstream research teams can, or in addition to us, can do things like query analytics, identifying the top queries or most valuable products, most valuable documents, content to create, these types of things, and for other downstream research purposes. Next, you've deployed some machine learning algorithms. How do they actually integrate within your search pipeline, right? Are you doing a lot of custom code to do that? Does it scale? And you've also developed some algorithms. What other common algorithms, and when I say common, I mean common problems that we see in search. Are you re-implementing those algorithms? Maybe you can use something that's already been done. That's something to consider, right? Until you start getting to more business specific problems where a lot of your machine learning and data science resources should be focused. Next is you're a big company, you have tons of data scientists, and you have multiple search vendors that help you to deliver the best experience to, let's say, your millions of users at scale. Oftentimes we see this challenge with model deployment. It takes weeks to deploy a model. Some of our clients want to get it down to a week, right? And some of that is both a process, right? Doing all of the testing to get things into production, in addition to the actual infrastructure. Are your models scalable out of the box? And how easy is it for a data scientist to deploy algorithms? So we're going to move a little faster here. And next, we're going to talk about what we offer from a machine learning perspective in Fusion and how that applies to e-commerce and digital workplace. First, we're going to start with query understanding. These are the algorithms that we give you, right? Boosting the signals, optimizing the queries, detecting misspellings, and having query intent models to understand maybe what's the best category for a particular query. Next, from a recommendation standpoint, we've solved the cold start problem in 5.2, so we can give you recommendations without you having signals. So there's no need for this warm-up period of collection, and you're not delivering recommendations to your users. And you have several different flavors. We have collaborative filtering recommenders that don't even look at the text. They just look at what users are doing to give you a more user-driven similarity, versus content-based recommenders where you can actually get similarities based on the text itself or the actual product description. Similar queries are very helpful for you to suggest alternate searches on zero result pages, in your type ahead, and put things like other people have searched for. Data science toolkit integration allows you to extend a platform. That's one we'll look at a little deeper in this talk. And we think this is one of our flagship offerings, because oftentimes it's very hard for you as a data science team to solve the problems of the business being constrained by the 10 algorithms that a vendor gives you. Fusion SQL allows you to do SQL-like processing on top of Solr, right? That's quite unique. You get this full text search, and we'll talk more about that. And what's very exciting for us is the semantic understanding category, where we're offering deep learning question and answering, and we're also doing deep learning based zero result model resolution. So when you don't get an answer, can deep learning actually suggest a better answer, some better products for you? And knowledge graph enrichment, we have some deep learning embeddings internally, and we're working with some clients to maybe augment their own knowledge graphs so that they can have better search as well. For digital workplace, we're starting to get back into documents. So, doing name entity recognition, extracting names, locations, purchases, organizations from the text, automatically clustering those documents, classifying them at query time when they come in, labeling them, extracting statistically important phrases, and also doing that across different types of languages. Same thing, query understanding, as we saw before, right? Every search platform has queries and we process them natively out of the box. And recommendations now, I think, are very important. That's something you definitely want to walk away from this talk if you're not actually implementing it within your internal search platform, especially for competitive research, looking at or surfacing new things that people should be aware of because there's just a lot of data out there. Data science toolkit integration. This is also very exciting in this domain simply because there are lots of language models that are out there in the wild. And now you can bring those language models for extracting medical entities, financial entities, different things like that. You can do a lot of augmentation of your current machine learning capabilities through this feature. Fusion SQL once again, and semantic understanding. In the digital workplace environment, we see more of natural language questions being asked. So if you have question and answer pairs, we can train deep learning models on those. Or if you don't have that, we train directly on your documents to help answer searches that are not keyword-based searches. Let's move ahead. Fusion SQL, you're combining SQL functionality with search. At an overview, this is mainly for sort of business analysts to start doing query analytics. You're combining SQL with search and Solar math expressions. And this is quite unique in the marketplace. Some use cases, right? You can be exploring logs or any type of data, structured or unstructured, that is contained within Fusion. We have some very large customers that, they're doing data exploration on text in Solar across like 20-something thousand shards. And the advantages, as you see here, Solar is a full text-based search engine, but you can do large-scale aggregations at query time, which is quite interesting. You do get this notion of doing better time series, and I'll show you a slide after this where there's tons of statistical functions that you don't get in SQL that you can natively do. All right, so here's a just quick visualization on some data in Solar, right? So you're doing regression and stuff like that on data from Solar. It's not typically something you think about. And this is a slide that you can share with your technical team about some of the capabilities that they get. Let's talk about question answering. The main thing I want you to take away from here is we're moved away from a template-based approach, so doing chatbot integrations and things like that. So deep learning can handle the query variation that comes in from your users when they ask questions in different ways. As I said before, it's going beyond a template-based approach. We're leveraging the knowledge you already have within your organization, and these are some of the use cases, okay? Call center deflection, IT, support tracking, and general semantic search in the workplace environment. Here are two quick examples. Can my wife drive on my insurance? And you can see on the left here other similar questions. Can my girlfriend drive on my car insurance? And in the middle, you see the answers. Same thing, is it compulsory to have home insurance? You can see it as learning the similarity between legal requirement and compulsory, these types of things. So that's the power of that language model. And as we take it home here, I want you to always think about, can you solve the problems unique to your business without doing infrastructure changes? And we think with this feature, you can. First of all, we do not limit you by our algorithms, right? The intention of our algorithms are to get you up and running very quickly so that you can focus on more significant problems. We do not claim to be the expert on your data. You data scientists on your side spend a lot of time, and we just want you to be able to deploy that expertise. At a high level, it's you can do this at query and index time, right? To either extract things from the index time or extract things from the query at query time. It's scalable. In addition, the process is quite streamlined. Essentially, you train a model locally, you deploy and publish a Docker container to a private or public repository. We pull that into Fusion, and then you just add a pipeline stage and you're more or less off and running. Lastly, the reason why we did this is so that you can focus your data scientists on the most impactful problems in the business, right? They shouldn't be solving problems that have been solved already. Just get up and running and focus on the problems that are unique to your business and your users and helps you to compete in the marketplace, or just, surface good things. For the future, some things we're looking at are, documented product relationship exploration, right? So if you use deep learning embeddings to actually look at, how documents are similar, how products are similar, driven by all of this data, in addition to text to image. Similarities is something very important that we're exploring. And overall, like I said in the beginning, hopefully you understand a little more about signals and you care a bit more. And I encourage you to even see if you can squeeze anything more out of what you're doing. Hopefully you understand what we've offered from a machine learning perspective and how you can use that to extend your own capabilities. And lastly, you can always bring your own machine learning into Fusion to deploy. So you have a single platform, no infrastructure change, and your data scientists can continue to provide value. Lastly, if any of these components interest you at an individual level, definitely reach out to me. If you're also interested in partnering on doing query analytics, understanding what the most important products are, and doing query distributions, and really getting the most out of your signals, I'm open book and look forward to speaking with you. Have a great day.